row major versus column major is an important concept to understand if you want to make sure you are getting the most out of your code. So what I have here is a bad example of what you should do on a row major system. I know my system is row major, however, my access pattern in this bad example is actually column major. We're looping through the columns and then we're looping through the rows. That is not ideal. What I should be doing is I should be looping through the rows and then be looping one by one through the columns. And the reason for this is because our memory, since we are in a row major system, our rows are going to be stored closer in memory address to each other. And when we go to DRAM to access memory, we're going to be getting 64 bytes of data every single memory access, not just one piece of data. But let's say we access the element in this row and then row 1 and then row 2 sequentially. What that will cause, eventually we will get too much capacity in our top level caches, and we'll then have to replace cache lines. But if we instead accessed all the elements in row 0, and then all the elements in row 1, and then all the elements in row 2, we will be accessing spatially local elements, and we will have to go to main memory less. And we'll also have fewer cache misses. So now that we've identified something that could be an issue, let's see what the performance looks like. Let's compile this code and then let's run it. Okay, so we have a total of 290 million cache misses, which is not great. It's about 16% of all cache references. Could be better. This is relatively what I was expecting. So let's now go and write the proper row major version. We're gonna copy this. We're gonna just change 2 lines, really. We're gonna call this good 2D. We're just gonna reverse these for loops, really. We're gonna comment this out. I'm gonna call good 2D. We're gonna compile that. I'm gonna run that. And as we can see, we've already gotten the amount of cache misses down tremendously. And it ran in about total more than half the time. These type of performance enhancements are everywhere in people's code. If you look for them, this is a nice little thing to understand. This becomes more important when you start writing GPU kernel code, but that's a whole nother discussion for a whole nother day.